with custom where they had very low prices of tryptophan, so that made it incomplete.
My name is Dr. Barbara McGoldrick. I'm a faculty member in the chemistry department here at Union County College. As you can see, the lab is a busy place. Today this video will serve to orient you to our facilities and to demonstrate safe laboratory practices. As a beginning student, you would probably be scheduled right here in room N15 or next door in room N13. Before we look at either of these two rooms in any detail, I'd first like to give you an overview of the entire laboratory area. If you enter through N13, the prep room is on your left and the stock room is on your right. Both these areas are off limits to students. As you walk through the short corridor, the next door ahead opens into Lab N13. Both hallway doors, N15 and N17, open into a common lobby. Now, the stock room is on the left and a chemical storage room is on the right. Students are not allowed in these areas. Lab N15 is used by beginning students. The third lab, N17, is usually used by upper-level organic students. Here's the N15 entrance. This large blue bulletin board is for you to check. The chemistry department will post such things as class schedules, faculty office hours, and answer keys to exams. If you don't recall what experiment is planned for the next lab meeting, here's one place to look. The entrance to laboratory N13 is one door down the hall.
Rooms N13 and N15 are nearly identical. As you enter, you may use the coat hooks located in the front of the room. The bottom drawers at all the lab benches are empty and are for you to use to store books and personal belongings. Notice there are no chairs. The aisles are kept clear for emergency purposes. Please do not leave book bags on the floor.
The first test is Molish test.
Usually your lab session will begin with a short pre-lab lecture. Dr. Khan is announcing special safety precautions and procedure changes before students start working. If you arrive late, you will miss these important announcements. It's your responsibility to check in with your teacher, not another student, before beginning any lab work. Each student works alone during the lab period, following the procedure in the manual and recording data as the experiment progresses. Calculations and questions are completed at your lab station, and the report is handed in at the end of the 3-hour time block. Your instructor will return your graded paper to you the following week at the next lab meeting. If you should need your report before the next lab meeting, your instructor may leave your graded paper in a designated folder in the N15, N17 lobby area. It's your responsibility to pick up your report if you wanted to study for a quiz the following week. The lobby area is open beginning at 8 a.m. Monday through Saturday, and in the evenings, Monday through Friday. Now let's preview what to expect during those 3 weekly hours of working lab time.
Before beginning any lab work, you will need to put on your goggles. Goggles must meet requirements for impact resistance and splash protection. Any of the types you see here are acceptable. This goggle is sold in any hardware store as a painter's goggle and can also be purchased in the bookstore. All of these provide full protection to the eye because they form a seal flush to the skin to protect against chemical splashes. This type of safety glass is not acceptable. It does not provide splash protection. Contact lenses should never be worn in the laboratory because they can trap harmful vapors and block full irrigation of your eye with the eye wash should that become necessary. You will have a contact lens waiver to sign, indicating that if you wear contacts, you do so at your own risk. Goggles must be worn throughout the entire lab period. It is tempting to take off your goggles when you've finished your experiment and are working on your write-up. However, the student next to you might still be working, or chemicals might still be out in the room. Therefore, your goggles do have to stay on. You can take a break, though. With your instructor's permission, you can always leave to sit and finish your write-up out in the commons.
Besides goggles, there are other safety measures to take before you start working. Tie back long hair so it doesn't hang into a burner flame. Remove dangling jewelry that could chip glassware and get in your way. Cover yourself to protect your skin from chemical spills. Use gloves to dispense corrosive chemicals.
Wear comfortable shoes. Sandals are not permitted.
Needless to say, no food is allowed in lab. Many chemicals are harmless to your skin, but are not harmless when ingested. Be sure to wash your hands when you leave. Quality hand soap is in the dispensers on the walls at either end of the lab. The laboratory coordinators prepare for every chemistry experiment in the different courses offered by the department. Mrs. Muscanera is making up a cart with all the chemicals and special equipment needed for a particular experiment. Each course has its own cart for the week's experiment. At the end of the experiment week, she'll dismantle the cart and the setup for the next week. For this reason, chemistry department policy dictates that, with the permission of the instructor, a student may only make up a lab during the same experiment week as the absence. When taking a chemical from the cart, it's important to read the label carefully. Don't automatically pick up a bottle that someone else has just put down. Do ask your instructor if you're not sure what to use. Using the wrong chemical can be very hazardous. Be absolutely sure of what you are using before you use it. Careful label reading is one of the most important lab safety rules to follow. Chemicals that are particularly corrosive or are in limited supply might not be placed on the cart, but might be isolated so that students could use them one at a time and with plenty of elbow room. The fume hood is one space used as an isolation area for chemicals. If the fume hood is to be used, your instructor will tell you at the start of the lab period.
Use for chemical distribution is only a secondary function of the hood. The main purpose of the fume hood is to isolate and remove noxious vapors from the laboratory.
Only one person at a time is permitted to stand in front of the small hoods in room N13, and 2 persons in front of the larger hoods in labs N15 and N17. This ensures full airflow around each person without blocking the opening of the hood. The hoods are unsafe with more people standing in front of them. This red indicator light signifies that the fan is operating. There is no switch to operate the fans. They are on continually. If the red light should go out, immediately lower the hood to its sill and notify your instructor. As much as an entire experiment may be performed in the hood.
The hood door may be placed in the full raised position in order to set up equipment. However, before beginning an experiment, the hood door must be lowered and locked in order to ensure safe draft. All of the hoods are not identical. However, there is water and gas supplied at each. The color-coded handles operate their use. The blue handle turns on the gas. The yellow handle, located on some of the hoods, is for a vacuum and is not operational. The green handle provides cold water above the cup sink in the back of the hood. Each laboratory is equipped with a handicapped hood designed for one person. This hose and attached nozzle may function as an eye wash as well as a shower.
To summarize, At the start of the lab, you've listened to your instructor for special directions. You know where chemicals have been placed. You've put on your goggles and started to get glassware and other equipment you'll need from your locker.
What typical lab techniques will you be using? What is the safe method of working? Hope and Saad are two UCC students who have completed their first level of chemistry. They will demonstrate safe laboratory techniques.
The balance you will use to make mass measurements is located on the ledge in the back of the laboratory. You will be using the balance pictured here or one very similar to it. A small brush for cleaning is located next to each balance. Be sure that the pan is clean before you use it. Nothing is ever placed directly on the pan. Pre-cut pieces of weighing paper are available next to each balance. Turn the balance on and wait for the display to read 0. Then cover the pan with the weighing paper. The paper mass can automatically be subtracted from the reading by depressing the Tare button. This re-zeros the balance. Now, Saad is ready to make a measurement. He removes the bottle cap and places it upside down on the bench top to avoid contamination. He's using a spatula to dispense the amount of solid that he wants. If he takes too much, he places the excess in the solid chemical waste jar, not back into the reagent jar. Once he's taken the appropriate amount of chemical, he recaps the jar, records the measured mass, and turns the balance off. The water bath is the preferred method of heating a test tube. This technique permits gradual heating and prevents the contents from popping out of the tube. A hot plate or a Bunsen burner can also be used as a heat source. If you are heating a flammable liquid, a hot plate is the only safe choice. For example, acetone, a very flammable liquid, is kept in these red squeeze bottles. Never use a Bunsen burner when acetone is being used. Special precautions need to be taken if direct heat is used. Hope is demonstrating safe technique here. She's holding the tube with the test tube holder and taking care to permit the flame only to heat the sides of the tube, not the bottom. Heating directly on the bottom could cause the liquid to pop suddenly and bubble up out of the tube. She directs the mouth of the tube away from her face or that of her neighbors. To check for the odor of vapors, she doesn't put her nose right over the tube, but uses her hand to fan the vapors towards her nose. Always use clean glassware and distilled water to prepare solutions. Saad is first going to illustrate how to safely dispense a liquid such as an acid. He holds the stopper between two fingers and pours slowly. The stopper is not in contact with the bench, where it could become contaminated or leave drops of acid behind. After pouring carefully, he touches the lip of the bottle to the lip of the graduated cylinder to prevent the last drop of acid from running down the outside of the bottle onto his hands. Saad also measures an amount of distilled water. He places the water in the beaker first. Water, the safe component, is present in a larger quantity. Then, if anything splashes up, it will already be diluted. Next, he adds the acid to the water. He's using the glass rod to stir and dissipate the heat. Again, he's touching the lip of one container to the other to transfer the last drop. At one time or another, all students will need to use the Bunsen burner. Burners, along with other hardware, such as ring stands and clamps, are located in the tall community lockers. Select a burner that's in good working order.
There are two moving parts on each Bunsen burner, the barrel of the burner and the needle valve. Be sure these turn freely. This hose connects to the gas supply at your bench. The blade valve is used to regulate the gas. The blade handle can be turned to the left or to the right in order to close the gas supply. The gas is full on when the blade handle is parallel to the gas jet.
Gas travels through the tubing and toward the needle valve. If the valve is tight, in the raised position, it will block the gas from flowing into the barrel. This is dangerous because gas could build up in the tubing and leak into the room. Be sure that when the gas is on, you've turned the needle valve to an open position, allowing gas to come into the barrel where it mixes with air. The amount of air is regulated by turning the barrel to open or close the air vents. The nature and temperature of the flame is controlled by the relative amounts of air and gas that are admitted into the barrel. Hope will show you how to light and adjust the burner safely. First, she connects the tubing. Hope opens the needle valve by 1 or 2 rotations, but no more. The amount of gas determines the height of the flame. She wants to be sure that the valve is only turned a little so the flame will be a safe height when she first lights the burner. The air vents should be open slightly. If they're open too far, the flame could strike back and she wouldn't be able to obtain a flame. Hope uses a striker from the community locker to ignite the burner. She turns the blade handle to the full on position and then squeezes the striker to light the flame. This orange flame deposits carbon on objects. It has more gas than air and is too cold for lab use. Hope rotates the barrel to increase the air and obtain a hotter blue flame. This is called a diffuse blue flame and is suitable for gentle heating. By increasing the air even more, she obtains a sharp inner cone and almost colorless outer cone. This flame provides strong heat. The tip of the inner blue cone is the hottest portion of the flame. Ordinary beakers, crucibles, and other objects to be heated are positioned just above the inner blue cone. Never leave a lit burner unattended. If you need to walk away from the bench, turn the burner off and relight it when you return. When Hope is done using the burner, she's sure to turn it off by the blade handle. Let the burner cool before putting it back in the cabinet. Not all chemicals are hazardous. Those that do pose hazards are the ones which can enter your body and cause damage. A chemical is considered hazardous if it is an irritant, or if it is toxic, corrosive, reactive, flammable, or carcinogenic. You can protect yourself from such chemicals by eliminating their route of entry into your body. The appropriate prevention measures are reviewed here. Inhalation can be prevented by checking for vapors carefully, using the fume hood when needed. Skin absorption can be prevented by washing hands often and using gloves when warranted. To prevent eye contact, always wear your goggles. Chemical ingestion can be prevented by eliminating all food from the laboratory and washing your hands before you leave. In addition to chemicals, glass poses a threat to personal safety. Hot glass does not look hot. Use a porcelain square to label a hot spot at your bench. Check the air around a heated object to be sure it's cool enough to touch. Chipped beakers or test tubes can cause injury. Dispose of all chipped or broken glass in the special glass garbage receptacles at the back of the lab.
In spite of preventive measures, accidents do sometimes occur. In front of each of our labs is a safety corner where first aid equipment is located. Your instructor might use the first aid kit for minor injuries. The red phone provides a direct line to the nearest security guard for assistance in an emergency. This red button is an emergency gas shutoff valve, which when depressed turns off the gas in the entire room. The fire extinguisher would be used for large-scale fires. Its use will be demonstrated later in this video. The red canister on the bench shelf contains a special sand-like material used to smother metal fires. The fire blanket is used to smother flames if clothing should ignite. The blanket is rolled up accordion style and unfolds with one pull on this strap. The shower would be used for a large-scale chemical spill. The larger ring turns the shower on. The smaller one turns the shower off. The circle on the floor marks the shower location. Use the sink for a small-scale spill. Saad just turns his cuff to eliminate the contact of chemical with his skin and rinses with cold water for a good 10 minutes. The two eye wash stations are located at either end of the room. The large red circle on the floor marks their location at the bench top. The use of the eye wash will be demonstrated later. Exits are clearly marked at the front and back of every lab. The end labs have exits to the rear leading into the courtyard. Lab N15 has two doors at the rear of the room that can be used as secondary exits into the adjoining labs. In addition to the fire extinguishers, all the labs are supplied throughout by a comprehensive sprinkler and alarm system.
In the event of any accident, be sure to notify your instructor as quickly as possible. Do not rush to help a student next to you who's had an accident. You could become another victim. Call your instructor instead. Use your porcelain square to put out small fires. For larger fires, the extinguisher should be used. First, pull the pin to unlock the handles. Second, direct the nozzle toward the base of the fire. Third, squeeze the handles to release the contents of the extinguisher. Use the sink for a small spill. Use the shower for a larger spill. The shower releases great amounts of water to dilute chemicals that may have splashed up on you. Pull the large ring to turn the shower on. Pull the smaller ring to shut it off. If a chemical should irritate your eye, don't hesitate to use the eye wash. It is operated by a foot pedal, which allows you the freedom to spread your eyelid apart in order to fully irrigate your eye. Flush for at least 15 minutes. A chemical spill on the bench top should first be diluted with water. Your instructor will take any additional steps if needed. You should immediately treat heat burns or chemical burns in the same way. Flush with cold water and call your instructor. He or she will take it from there. Ice will be used to prevent blistering, and an antibiotic cream or ointment may be applied afterwards.
A cut finger in the laboratory raises the possibility of exposure to blood-borne pathogens, such as hepatitis B or HIV, the virus which causes AIDS. The procedure used in the laboratory is called universal precaution. This means all body fluids will be treated as if they were infected. For this reason, you should never pick up broken glass or anything else that has punctured someone else's skin and caused bleeding. If you cut yourself, expect your instructor to first put on gloves before assisting you with antiseptic and a Band-Aid. Your best defense against injury in the lab is to practice prevention by following safety procedures. Know what you're working with. Handle chemicals safely. Report dangerous situations to your instructor promptly and follow the emergency responses outlined here.
When you've completed your experiment, be sure to dispose of chemicals according to directions. Never pour chemicals down the drain without your instructor's permission. Certain chemicals can corrode the pipes and ultimately contaminate groundwater. Special separate jugs are located in the hood for disposal of water solutions containing metal ions as well as for organic liquids. These do not go down the drain. Dry chemicals are placed in the solid chemical waste containers located on the bench shelves. With your instructor's permission, you may use the sinks. There are cup sinks located at your workstation, which you can use to obtain tap water or to dispose of designated wet chemicals. The cup sinks should never be used to dispose of solid or paper waste. You may use the large sinks at the end of each bench to obtain water or to dispose of liquids. Liquids must be cool before you pour them down any of the drains. Liquids above 140 degrees Fahrenheit damage the plastic joints under the sink. Running cold water with hot liquids is not acceptable. Wait for liquids to cool before disposing. Please do not force the paddle handles. Water naturally drips from the gooseneck after the water has been turned off. Depressing the paddle handles further only damages the washers. The eye wash should never be used as a sink. Waste paper baskets are only for paper. To keep the aisles clear, these paper refuse containers are concealed in the cabinets under each sink. Before leaving your bench, wipe down your work area with a wet paper towel. Wash your hands with soap, then hand in your report.
I hope this video has given you an idea of what to expect when working in the lab. On behalf of the chemistry department, I'd like to welcome you to the UCC laboratories. Do work safely, and I'm sure you'll enjoy the time you spend here.